Hi, good morning everyone. This is Mr. M from Algebra Lessons. Today we are going to discuss about exponential function, specifically solution of exponential function. So let me write solution of exponential functions. This so there are different cases. Today in this small video we are actually discussing the case of the exponential functions with same base. Okay, how we can solve exponential function with same base. I hope you know the very basics of exponential function. In this case, we are using one property that exponential function is always satisfying. So we are actually going to use that property here. So that property is called one-to-one property. One-to-one property. This is actually an important mathematical property we can use in several situations. Specifically in this exponential function scenario, the one-to-one property can be explained as for any real number, for any real numbers b, s, and t. B, s, and t are some arbitrary numbers, and here this b should satisfy some conditions. B cannot be less than 0, that means b cannot be a negative number, and b cannot be equal to 1. Okay, these are the two important conditions. That is actually the condition for the exponential function also. If that b, s, and t satisfying all these conditions, then we can write the one-to-one property as, let me use a different color, the one-to-one property as b to the power s equal to b to the power t. See, here we have both bases are same. Here the base is b, here also the base is b. We are actually discussing the exponential function with same base. So here we actually defined a property, that is one-to-one property. If we have three numbers b, s, and t, and condition for b is b should be positive and b cannot be equal to 1. If that condition satisfying, then b to the power s is equal to b to the power t. If b to the power s is equal to b to the power t, then we are actually reaching our destination. Then s is equal to t. S is equal to t. This is what is called one-to-one property for exponential function. Okay, so let me use this property. Let me use this property for solving equations, exponential equations. I can show you one example. The problem is find or solve 5 to the power 2x equal to 5 to the power 3x plus 2. 5 to the power 2x is equal to 5 to the power 3x plus 2. So as we know, because of this one-to-one property, if b to the power s equal to b to the power t, so what we need to check here in this equation, in this exponential equation, what is the base? Here the base of this equation is 5. Here also the base is 5. That means we can see that the base of both the both the exponential terms are same, and that means this is actually an exponential equation with same base. So we can use the one-to-one property. What it is saying, if b to the power s is equal to b to the power t, so we can, if we have two exponential terms with same base, so then we can equate its exponents. That is what is the one-to-one property saying. So we can equate the exponents. Okay, so 2x That means, so the solution 2x, because of the 1-to-1 property, 2x is equal to 3x plus 2, and eliminate 2 on both sides. Yeah, cancelled out. So 3x is equal to 2x minus 2. Eliminate 2x on both sides. Subtract 2x on both sides. Yep, cancelled out. So negative 2 equal to 3x minus 2x is x. So we have the solution. X is equal to minus 2. So when x is equal to minus 2, the equation will be 5 to the power 2 into minus 2, okay, equal to 5 to the power 3 into minus 2 plus 2. 5 to the power 2 into minus 2 is 5 to the power minus 4, equal to 5 to the power 3 into minus 2 is minus 6 plus 2, that is 5 to the power minus 4, equal to 5 to the power minus 4. So the equation is satisfying both LHS and RHS is same. So we can say that that solution is true. So this is the way we can use the 1-to-1 property to solve exponential equations. Okay, let me show you one more example that will give you more idea or more sense about using this kind of property. So let me write another example. Okay, so example 2. 5 to the power 2x equal to 25 to the power 3x plus 2. See, here the situation is different. If we know that if the base of the exponential equation is same, we can use the 1-to-1 property. So if the exponential the bases are different, how can we make it same? There may be chances to make it same, so we can try. So the solution part is this. So 5 to the power 2x, just for convenience I'm writing the question again. It is 25 to the power 3x plus 2. So we know that 25 means 5 to the power 2. So we can connect 25 with 5. So rewrite here. So that is 5 to the power 2x equal to, what is 25? That is 5 to the power 2 to the power 3x plus 2. So we can use the power of power rule here, the rule of power. So that is 5 to the power, multiply this exponent with the external power. So that is 2 times 3 is 6, 6x plus 2 times 2 is 4. Yep, we actually made it same. So 5 to the power 2x is equal to 5 to the power 6x plus 4. Now we know how to solve this because we used the 1-to-1 property before. So this is at this point we can write, because the base is same, so we will equate the exponents, that is 2x equal to 6x plus 4. So eliminate 4 on both sides, cancelled out. So 2x minus 4 equal to 6x, eliminate 2x on both sides, cancelled out. So minus 4 equal to 6x minus 2x is 4x, eliminate 4 on both sides, because we are trying to isolate x. That is what I'm doing all these operations. So x is equal to 4 by 4 is 1, but it is negative, so x is equal to minus 1. This is actually the solution of the given equation. So I'll conclude this video by showing one more example. That will be the final example. So example is 2 to the power 5x is equal to square root of 2. We have a radical came here. Or we can say that this is a question that we can convert into a rational exponent. Let me try. So the solution can be start like this. Write the question once again. That is actually my style. I'm always writing the question to start the problem. Okay, so 2 to the power 5x is equal to root 2. What is root x? Root x is x to the power 1 by 2. That's a great idea. So that means this number comes out as the base. Okay, so 2 to the power root 2. This is square root. So that is 1 by 2. We have a rational exponent, but we know that as per the 1 to 1 property, we can equate the exponent. So that is great. So 5x is equal to 1 by 2. So basically we need to isolate x, but before that we can try to eliminate this fraction, because keeping fraction is not a good idea to get the right answer. So I'm trying to eliminate the fraction by multiplying 2 on both sides. So 10x is equal to 1, yeah, because 2 and 2 got cancelled out. So from this, x is equal to 1 by 10. So this is the actual answer, the solution. So these are actually the type of problems arise when you are actually approaching the problems with same base, the exponential equation with same base. These are actually the only kind of problems can arise to solve. So I hope everyone actually understand the concept that I explained. I'll come up with another video. Thank you for this time. Bye.